Hello everyone, welcome to our final presentation. For our project, we decided to create an easy-to-read sentence generator for people with intellectual disabilities. Why do we need to do this work? People with intellectual disabilities face difficulties concerning their attention, memory, ability to use abstract thinking. Therefore, during daily basis communication, straightforward sentences should be used. By implementing our algorithm, we hope to bring a chance of adjusting a sentence to the abilities of readers on different comprehensive skill levels. There is a couple of previous approaches on this topic. First one is Access, a sentence simplifier that filters data based on four different criteria: the amount of compression, paraphrasing, lexical, and syntactic complexities. But these features are used for filtering and not for training the model. Second approach is to use multiple type of inputs. In order to handle two different inputs, two works done with multiple inputs were investigated. On the left side, the visual transformer passes class embedding and patches of an image. On the right side, the multimodal transformer passes different features. Third one is also transformer based. It prevents output sentences from using difficult words by using a loss function that multiplies their frequencies. Last one is called dress, which uses three rewards in the reinforcement step: simplicity, relevance, and fluency. So, what does an easy sentence look like? For people with intellectual disabilities, a sentence is easy when it does not contain multiple informations in one sentence, doesn't use ambiguous or difficult words. The sentence should be also short. After analyzing previous works, we settled for 5 different features describing easy sentence. Number 1. Number of sentences. Splitting a sentence into separate ones increases its readability. Number 2. Number of commas. Commas are usually used to provide details that might be unnecessary to a reader with concentration issues. Number 3. Number of stop words per sentence. Stop words increase the sentence difficulty. Number 4. Number of words per sentence. The less is the better. Number 5. Proportion of easy words. We use top 10,000 most commonly used words on Google as an indicator of easy words. Our feature extraction is done in 3 steps. Firstly, we calculate the values for each 5 features in source and destination sentence of our dataset. Next, we calculate the ratio of each feature values. We use this value as a feature score. Our model is transformer-based. It takes 2 different inputs: the sentence to simplify and the target feature score of simplified sentence. Target feature score is passed to the linear layer. We use cross entropy as a base loss and calculate new weighted loss. For that, we multiply the cross entropy by weight. We calculate the weight using MSE, so the importance is put more to generating meaningful sentences rather than desired feature score sentences. The weight was set as shown in the slide.
For our dataset, we use Wiki-Large, a dataset with original sentences mapped to easy sentences. We divide the dataset into almost 300,000 of training data, 992 of validation data, and 359 of the test data. For the training process, we tried a transformer without feature score, a transformer with base loss, and a transformer with weighted loss. Here, you can see the performance of each of the training on a different EASE evaluation. Cross-entropy model was good, but weighted loss still performed better. Our model produced easy sentences well. For feature scores, cosine similarity between the target feature score and the feature score of the generated sentence was calculated. The similarity is higher for all features in a weighted loss model. Here are example results of our model with different input target feature score and an input sentence. As you can see, target features were changed to control the number of words in a sentence. Here, target feature scores of number of sentences and commas in a sentence are controlled and produce different output. You can see the demo of our model by going to the link on this slide. You can write the input sentence in the box and change the target feature value. The output of ours and baseline model is shown after clicking on the Submit button. Of course, our work has some limitations as well. Due to limitation of our vocabulary size, the easy synonym conversion did not go well. When increasing easy word ratio, the sentence length increases by repeating same word. We had issue with training time, so we used vocabulary size of 50,000 and 10,000 of easy words. With increased vocabulary size, this problem will be solved. Lastly, pronoun transformation was not smooth when doing sentence separation. When combining with other models, this issue seems to be resolved. Summarizing, we have created an easy-to-read sentence generation model with its features targeted towards people with intellectual disabilities. Weighted loss showed the best performance among all. Our RL model was not finished on time. Our work contributes to AI for people with disabilities. Feature work should include making more user-friendly features and setting features automatically for brief tests. Thank you for listening to our presentation.